Have you ever been stuck trying to make a big decision when you just don't have all the facts? We all have. Well, today, we're going to unpack a really powerful way to think through those tough choices. And it all comes from a super interesting research paper on this exact problem. So let's just dive right in with a scenario. Imagine you're the CEO, you've got 3 amazing R&D projects on the table. Any one of them could be a massive win. But, and it's a big but, you've only got the budget and the team to focus on one of them this week. So, how do you choose? Which one do you bet on? All right, here's how we're going to break this down. First, we'll look at the core problem, this idea of potential. Then, we'll explore a classic thought experiment called the gambler's dilemma. After that, we'll add a really cool twist. What if your options can actually get better? We'll look at a strategy built for optimists, see how it did in a real-world test, and then, most importantly, we'll talk about how you can use this exact thinking in your own life. So this isn't just about a single choice. It's really about the ongoing challenge of where to put our most valuable resources, our time, our money, our focus. When we're facing a bunch of uncertain but promising opportunities, every single choice has consequences. And this is really the heart of it, right? Every choice you make comes with an opportunity cost. If you decide to work on Project A, you learn absolutely nothing about Projects B and C. And that's a real cost. When the future is basically a black box, you can't just guess. You need a much smarter way to play the game. Well, it turns out there's a classic name for this exact kind of problem, and it's called the multi-armed bandit. The easiest way to get your head around it is to picture a gambler walking into a casino and seeing a huge row of slot machines. Each of those slot machines, those one-armed bandits, is what we call an arm. Now, each one has a totally different and totally unknown chance of paying out. Your goal? Simple. Maximize your winnings. But here's the catch. You only get information about the one machine you choose to pull. The others remain a mystery. And this leads us to the fundamental tension in all of these problems. It's the battle between exploration and exploitation. Do you explore, meaning you try out a bunch of different machines, gathering information and hoping to find the secret jackpot? Or do you exploit? You find one machine that seems pretty good and you just stick with it to maximize your immediate cash. It's a tough balance. Explore too long and you're wasting money. Exploit too soon and you might miss out on a much bigger prize. So how do we measure if we're making good choices here? We use a concept called regret. And no, we're not talking about feelings. This is pure math. Regret is the difference between what you actually won and what you could have won if you'd magically known the best machine from the very beginning. The goal of any good strategy is to keep that number, that regret, as low as possible. Okay, this is where the research paper we're looking at takes a massive leap. It goes beyond these fixed, static choices and asks a really powerful new question. Think about it. What if those slot machines weren't just fixed boxes with set probabilities? What if every time you pulled the lever, you weren't just getting a random reward, but you were also learning how to tune that machine, how to make it better? You see, this completely changes the game. In the classic problem, your goal is just to find the best button to press. But in this new functional bandit problem, your world is a set of systems you can actually improve. Your goal isn't to find the best button, it's to find the best system to work on. And this brings us to the paper's main idea, the Functional Multi-Armed Bandit, or FMAB. Now, each arm is a complex system, a black box function. You know the inputs, you see the outputs, but what happens inside is a mystery. Think of an AI model, or a marketing campaign, or one of those R&D projects. Every time you work on one, you're not just getting a result. You're taking a step towards finding its absolute best, most optimized state. Okay, so we have this much more complicated but much more realistic problem. How on earth do you solve it? Well, the paper gives us a really elegant solution, and it's called the F-LCB algorithm. It's a strategy for optimists. Now, before we get into it, let's just clear up one technical term, oracle. It sounds pretty mystical, right? But it's actually super simple. An oracle is just whatever gives you feedback. If you spend an hour training an AI model, the oracle is what tells you its new accuracy score. It's just the thing that reports back on how you did. So here's how this FLCB strategy thinks. It's actually pretty intuitive. First, it just dips a toe in the water with every option, tests each one briefly. Then, for each option, it estimates not just how good it is right now, but how good it could potentially be in the future. It sees uncertainty as an opportunity for growth. Then it picks the single option with the most optimistic upside and puts all its resources there for one round.
Then it does the whole thing over again. It's always betting on potential.
Now, this isn't just some abstract theory. The researchers put this strategy to the test on a very real, very expensive, and very complex problem, trying to find the best type of AI model for recognizing images. So, in this experiment, each of these models was an arm. As you can see, they're all about the same size, but their internal architecture, how they're wired, is completely different. The challenge was to figure out which of these structures was best at learning to identify images.
So how long did it take the F-LCB algorithm to intelligently test all these complicated models and figure out which one had the most potential? Get this, just 9 minutes. It quickly zeroed in on the winner, which turned out to be the ResNet 18 model.
And here's where you really see the power. A more traditional, naive approach took 19 minutes to find that same winner. The F-LCB algorithm was more than twice as fast. In the world of AI, that's a massive saving in computation, which directly translates to saving a lot of time and a lot of money.
Okay, so let's bring this all back home. Why does this matter to us? Well, this way of thinking isn't just for data scientists. It's an incredibly useful mental model for making better decisions in our own lives, anytime we're facing that classic trade-off between exploring something new and sticking with what we know. Think about it. It's the CEO deciding which project to back. It's the marketer looking at 5 ad designs and wondering which one is worth improving. It's a chef with 3 new recipes, trying to figure out which one has the potential to be a star. And it's you, wondering if you should spend your next 10 hours getting better at coding, learning an instrument, or practicing a new language. This is the core idea, the whole thing in a nutshell. The smartest strategy is to always work on the option that looks the most promising, that has the best balance of being good now and having lots of room to get even better. And that's the big takeaway. It's about asking a better question. Stop asking what's the best choice right now and start asking what is the best thing to work on right now. Because sometimes the thing that looks a little clumsy at first might have way more potential than the current frontrunner. It's a dynamic, forward-looking way to make decisions. So, I'll leave you with this question to think about. In your life, in your career, your hobbies, what are your arms? What are the different systems you could be putting your energy into? And more importantly, which one has the most exciting potential? What's the best thing for you to start working on right now?